Welcome to Vision Plus and welcome back to this S.4 Mathematics. We are looking at differentiation and we are using method 1, that is dealing with powers and coefficients. Example 3 says differentiate the following functions. Part A, the function is given as y equals to x cubed plus 2x squared plus 3x. So let us differentiate this function of y. So we shall say dy dx, that is differentiating the function y with respect to x, gives us, we shall lower this power, which is 3. There is a coefficient of 1 here that we know. So we shall have y times 3. Then we say x. Now we need a new power here, which becomes the whole power minus 1. So we have differentiated the first term. And then we go on to say plus. Now we come to the second term, which is 2x squared. We shall lower the power, which is 2. And there was a coefficient of 2 here. So we shall say the coefficient, which was 2, times the power that we are dropping, which is also 2. So 2 times 2, x. Now we need a new power here. How do we get the new power? It is the old power, which is 2 in that case, minus 1. And then we have differentiated the second term. Then plus. Now we differentiate the third term. The third term is 3x. So this x here has a power of 1. I should know that. That means coefficient of 3 times the power, which is 1. Then we say x. Now we need a new power of x, which is the old power, which is 1, minus 1. Remember, we always subtract 1 from the old power so that we can get the new power. Now we have differentiated all the terms. Now we need to just simplify. 1 times 3 is 3x. 3 minus 1 is 2. Plus 2 times 2 is 4. X 2 minus 1 is 1. Plus 3 times 1 is 3. X 1 minus 1 is 0. Then we completely or further simplify. This gives us a 3x squared plus 4x plus 3. So this is the derivative of the function in part A. Remember, if you are differentiating something, okay, if you are differentiating an expression, you can get a constant, okay, which you write. It is only when you are differentiating a constant that is when you get 0. So don't think this 3 is going to be 0. We are not differentiating the 3, but the 3 we have obtained is as a result of differentiating a given number 3x. So you must take note there. Going to part B, our markers are stubborn. Part B says, the question says, we have y equals to 4x power 4 minus 3x squared plus 5. And that we need to find the derivative of that function, how we differentiate it. Now this means that we're going to say differentiating y with respect to x, dy dx equals to, we have a coefficient of 4 there, times drop the power, which is 4, then you attach x. Now we need a new power, which becomes the old power of 4 minus 1. We have differentiated the first term. Then we say minus. Put the minus down here, don't put it up. It might appear like it is a power. And then we have here coefficient of 3. So 3 times drop that power of x, which is 2. And then x, then we get the new power, which becomes 2 minus 1. We have differentiated the second term, plus. Now 5 is a constant. Why? It is not attached to x or y. It doesn't have a variable attached to it. So if you differentiate a constant, we get 0. Don't confuse it with what I explained here. 3 was a constant obtained as a result of differentiating a given expression or a given function. It was 3x. So now from here we simply simplify. 4 times 4, 16, x power 3 minus 6x. And this is the answer because this is the power 1, which is the same as 6x. So that is the answer in part B, simply in that manner. And then going to part C. Part C says we have the function y equals to 2x minus x squared. What do we do here? We say differentiating the function y with respect to x, which is a variable, dy dx becomes, this x here has a power of 1, and we can see that. So we need to lower that power, giving us 2 times 1, which was the power x. Now we need a new power here, which is the old power, which was 1 minus 1 of the formula. Now we have done that. And then minus. If you look here, there is no number. That means we had a coefficient of 1. Okay? Coefficient of 1. And then you drop the power. So we shall say here times 2. Now we need a new power of x. So here we shall have x. The old power is 2 minus 1. This minus was for the function. It is still here in the derivative. This now gives us 2 times 1 is 2 x. 1 minus 1, 0. Minus 2 times 1 times 2, 2. X, 2 minus 1 is 1. Then we simplify. Any number to power 0 is 1. 1 times 2, 2 minus 2x. There is 1 there, but we don't write. So this is the solution to part C. And this is the overall solution to example 3 when we are going step by step.